So we're going to look at phase diagrams in a little bit more detail here. We're going to look at one other kind of interesting fact, and that is liquefaction. We can liquefy something like a gas by applying pressure. So butane is a hydrocarbon with 4 carbons. It looks something like this, and we know that the butane in a butane lighter is actually a liquid, but when we press the button and let it out, it becomes a gas. So the question is, why is this? Well, if you look at the phase diagram for butane, in fact, maybe you can pause this video here and label the phases. Okay, if you unpause, then you should be able to label the phases here. So this is high pressure and low temperature. This corresponds normally to a solid phase. And down here, we've got low pressure and high temperature. So that is a gaseous phase. And in between, we've got a liquid phase. We also have our triple point. And the last point along this line here would be the critical point. And past here, there's actually no difference between liquid and gas. It is a, do you remember what it's called? Yeah, it's a supercritical fluid. So again, remember, most substances have this line here that has positive slope between solid and liquid. That is to say, as you increase the pressure, the temperature at which it takes to melt something increases. Water is one of those weird exceptions that actually has a negative slope. So we can go ahead and we can liquefy butane. So we know that butane is normally a gas. And so at a particular temperature, maybe room temperature, right? So we'll say 1 atmosphere. We know that it is in this region of the phase diagram, so it's a gas. And of course, how do we liquefy it? How do we get it to fit inside a lighter with very small volume? And the answer is we just raise the pressure. And so if we raise the pressure, essentially we are moving in the vertical direction here. And so if we move the pressure up to say 5 atmospheres, let's say, maybe it corresponds to this point right here, we've essentially turned it into a liquid. And we know that liquids have a much smaller volume than gases, so we can squeeze a lot more butane in a lighter, let's say this way. And let's take a look at dry ice, so carbon dioxide's phase diagram. So again, we're going to work with pressure temperature phase diagrams. And we're going to go ahead and have, let's draw this in yellow, right? So that looks pretty cool. So there's our triple point right here. And those are our phase boundaries. So this is solid at high pressure, low temperature, gas in reverse, and liquid in between. We got a supercritical point there. So past there, we've got a supercritical fluid. And we'll see that this triple point right here corresponds to a temperature of minus 57 degrees Celsius, and this critical point, this triple point pressure corresponds to something like 5.1 atmospheres. So actually on a normal day, right, where the pressure is hopefully very close to 1 atmosphere, if we take carbon dioxide and we warm it up, right, then it simply just moves from the solid to the gas region. So this is sublimation. It doesn't melt at all. Now, once we get up above 5 atmospheres, right, we can see that you can go from a solid to a liquid. So you can melt carbon dioxide. You just have to be above a pressure of about 5.1 atmospheres. But if you're below that region, then it's not going to melt. It's just going to sublimate. Another really neat feature is that this critical point temperature corresponds to something like 31 degrees Celsius. So it turns out above 31 degrees Celsius, there's no such thing as liquid or gaseous carbon dioxide. It is just a supercritical fluid. It completely fills the containers, and it has very awesome, weird, wonderful properties. And if you've ever got a carbon dioxide fire extinguisher on a very hot day above 31 degrees C, if it's below 31 degrees C, you actually have a liquid inside. You can shake it up and you can hear it sloshing around as the liquid and gas phase kind of interchange. But if you leave it out in the sun on a very hot day past 31 degrees C and shake it up, you don't hear anything at all because you've got a supercritical fluid inside the fire extinguisher, and it fills up the entire container, and you no longer hear that phase boundary between the liquid and the gas phase. Pretty cool stuff, huh?